So today we are going to discuss part 9 Core Java API and under that part 9.3 ArrayList, quite an important chapter. Let's focus on this. Okay. So ArrayList is Java's resizable array. It grows automatically as you add elements, unlike a plain array which has a fixed size once created. Okay. So you must import it from java.util. It is typically declared with a generic type in angle brackets, which tells the compiler what type of objects it holds, right? So writing ArrayList then within the angle bracket string means only strings can go in and you can get strings back without casting. Okay. Add with just an element appends to the end. Okay. So add with an index inserts at that position and shifts all existing elements to the right. To check the number of elements, we use size. This is a method called with parenthesis. Okay, size parenthesis. This is different from arrays where length is a field with no parenthesis. The exam specifically tests whether you write size with parenthesis or length with parenthesis on an array list. Okay, so we have to remember this. So for array list is size with parenthesis. So declaration is array list within angle brackets string names and then new array list angle bracket and parenthesis. So array list is Java's resizable array. Unlike a plain array which has a fixed size from the moment it is created, array list grows automatically as you add elements. You must import it from java.util. The string in angle brackets is the generic type. It tells the compiler that this array list will only hold strings. You get type safety at compile time and no casting needed when you retrieve elements. Array list, raw list is equal to new array list. Okay, so this is a raw type, no generic specified here, right? So you don't see any angle brackets within that string or any other integer or anything like that. So this is a raw list. Okay, so no generic is specified. It compiles and works, but the compiler gives you warnings because there is no type checking. Anything can go in and you need to cast when you take things out. The OCA exam recognizes this as valid, but it is not recommended. Okay. So adding elements, names.add say Alice and names.add Bob. Say add with just an element appends to the end of the list. After these two calls, the list holds Alice at index 0 and Bob at index 1. Okay. So names.add 0, Zara, right? So add with an index inserts at that position only. So everything from index 0 onwards shifts one position to the right to make room. Zara goes to index 0, Alice moves to index 1 and Bob moves to index 2. The list is now Zara, Alice and Bob. So we have to remember this, right? And how do we access system.out.println names.get 0? It will give you Zara. So get retrieves the element at the specified index. Index 0 is Zara. Then system.out.println names.size, right? And equal to 3. Size returns the number of elements currently in the list. So there are 3 elements, so it returns 3. And now notice it is size with parenthesis, okay, and not length with parenthesis. Okay, this is one of the most reliable exam traps. Arrays use length with no parenthesis. Strings use length with parenthesis. Okay, so array list use size with parenthesis. So these 3 are different things, one for each type. Exam will mix them up and exam ask which is correct. Updating. Names.set 1, Alex. So set replaces the element at index 1 with Alex. Alice at index 1 is gone and Alex takes her place. The list is now Zara, Alex, Bob, right? Sorting. Collections.sort names. So Alex, Bob, Zara, right? So collections.sort it sorts the list in a natural ascending order. Alphabetical for strings, numeric for numbers. So note it is collections with an S from java.util.collections, a utility class separate from the collection interface. Okay, so the sort modifies the list in place just like arrays.sort modifies an array in place. So after sorting it becomes Alex, Bob, Zara. Okay, so array list remove the index versus object overload trap. Okay, the remove method has 2 overloads and the difference between them is one of the most targeted traps in the array list section. Remove with an int argument removes the element at that position. It interprets the argument as an index. Remove with an object argument removes the first element in the list that equals the object. It interprets the argument as a value. For most typed array list, this is very straightforward. Words.remove apple clearly passes a string, so Java uses the object overload and removes by value. But for array list of integer, there is an ambiguity. When you write nums.remove, you are passing an int literal. So Java resolves this to the int overload remove by index. So it removes the element at position 1, and which happens to be the value 2 in our examples, not the value 1, right? So if you want to remove by value in an integer list, you must force boxing. So nums.remove integer.value of 1, right? So this passes an integer object, so Java uses the object overload and removes the value 1. So removing on a string array list is quite straightforward. So words.remove 1 removes with an int argument, removes by position, by index. Okay. So on index 1 is banana, so banana is removed. The left shifts, so cherry moves to index 2 to index 1, so list is now apple and cherry. Then words.remove apple, remove with a string argument, removes by value. So it searches the list for the first element equal to apple and removes it. List is now just cherry. For a string array list, this is clean and unambiguous, and int is clearly an index. Okay, so a string is clearly a value, so there is no confusion. Okay, there is no confusion. The integer trap. So here we have to understand this very carefully. So array list integer nums new array list angle bracket. Okay, and parenthesis. So nums.add 1, nums.add 2, nums.add 3. So it adds 3. Now we have an array list of integer objects. The values are 1, 2, 3 at indices 0, 1 and 2. So nums.remove 1. So we pass the int literal 1. Java sees an int and resolves this to the remove by index overload. So index 1 holds the value 2. So 2 is removed and not 1. The value 2 at position 1. Okay, so list is now 1, 3. This is the trap. You might expect remove 1 to remove the value 1, but Java resolves int literals to the index overload first. The value 1 is still in the list. Okay, so nums.remove integer value of 1. To remove by value, you must force boxing. So integer.value of 1 creates an integer object, not a primitive int. So now Java sees an object being passed and resolves to the remove by value overload. Okay, so it searches for the first element equal to integer 1 and removes it. List is just now just 3. The reason this trap exists is method overloading. Array list has two remove methods. One is remove by int access index and then remove by object o. When you pass a primitive int, Java always picks the int overload, and when you pass an object, any object including a boxed integer, Java picks the object overload. For string array list, you never see this trap because you cannot pass a string as an index. But for integer array list, the ambiguity is real and exam exploits it. Okay, so the fix is always the same, right? To remove by index, pass a plain int literal. To remove by value from an integer list, wrap it in an integer dot value of to force the object overload. Okay. Array list key method reference and array conversion. So converting between an array list and an array is a common operation, and the exam tests both directions. Okay. To array with no arguments returns an object array. To get a typed array, pass a typed array of the right size, or simply new string 0 as a type hint. Arrays.asList converts an array to a list, but the result is fixed size. It is backed by the original array. Changes to one are reflected in the other, right? So you can call set to replace elements, but calling add or remove throws unsupported operation exception because the underlying array cannot change size. Okay. So array list to array, there are two ways. The first way is object bracket array arr1 and then list to array parenthesis. This returns an object array. It works, but every element is of type object. So you must cast each element before using string methods. Second way is string then bracket arr2 and list dot to array new string 0, right? So this returns a proper string array. The new string 0 is just a type hint. It tells Java I want a string array back. You can now use arr directly, no casting is needed. Even though the array size is 0, Java automatically creates a new array of the correct size internally. So this is very important, okay? And this is used in OCA exams a lot. So array then list important trap. string source is equal to xyz, and list string list within angle bracket string fixed is equal to arrays.asList source, right? So this converts an array to a list quick and easy. But here's the catch: this is not a normal array list. It is a fixed size list backed by the original array. So what will work? Fixed.set 0, 0 comma within quotes x. You can replace elements, and since both share the same data, source 0 also becomes x. What will fail is that fix.add w, so it will be a runtime error. This throws unsupported operation exception. Okay. So why? Because arrays are of fixed size, so the list cannot grow or shrink. Same applies to remove. Okay. So important point is that this error happens at runtime, not compile time. Correct way: if you want a real array list, then within angle brackets flexible string flexible new array list angle brackets, then arrays.asList and source. Now you get a fully resizable list. You can add, remove anything. Okay.